There is a quality among all rectangles whereby if you have any given rectangle, we have two right here, like so. And if you draw a diagonal across corner to corner from, draw a right angle across that diagonal, like so, then if you draw from this point where the diagonal hits the edge of the rectangle, if you draw a horizontal line like so, and a horizontal line like so, what you get is a smaller rectangle here and here, which this smaller rectangle is the same ratio as the overall rectangle. Same thing happens here. This small rectangle is the same ratio as the overall rectangle. This is true of all rectangles. Now, there is one rectangle that has this quality plus an additional special quality that no other rectangles have, and that is the rectangle of the golden ratio. And that ratio is 1.618 to 1. And so that means that if you have a rectangle like so, the short edge is 1 and the long edge is 1.618. So this edge is 1 and this edge is 1.618. This rectangle has a special quality that these other rectangles don't have. Okay, in the golden ratio, or the 1.618 ratio, the idea is that you are taking this ratio and you're expanding it to where the 1.618 is 24. 14.8.33 over 24. So our paper here is 24 inches tall, 24. So the short distance is going to be 14.833. If you convert that to fractions, that is 14 7/8. Because I've got a scale here that is in fractions and not in decimals. So 24 by 14 7/8. You got your major diagonal and you got your minor diagonal intersecting at 90 degrees. And so at this point where you draw a line across where this point hits, what you get is a new situation where, as before, we get a smaller rectangle, which is the same ratio as the overall. That is, this smaller rectangle has this ratio of 1.618. And you have a remaining rectangle, but in this case, this remaining rectangle is a square. That means that it is 14 7/8 in this direction, and it's 14 7/8 in this direction. Now you have your square here, and you have another square here. And if you draw a line from here to here, this intersection will be 90 degrees. So the significance of a square in painting is that if you have a square here, and you put some feature from the composition along or relative to this line, it will take on some special significance because of the fact that there's a square configuration in its placement. Your eye can pick up the fact that it's placed on a square. It has this internal, your eye has an internal logic, which you're consciously not aware of, that, but your eye can pick up. It's sort of like a visual harmonic in music. Your ear can pick up octaves and various combinations of tones. In visual, your eye can pick up various geometric configurations, the square being one of the main ones it can pick up. So then we also connect up the corners with from here to here as well as from here to here. Now what happens when we do that is we get another interesting situation where this line intersects with this line and this line. So this, again, this is on the square. So it's intersecting where this major diagonal is coming across, and it's and where this is a diagonal across a square. So there's all these geometric coincidences that are cropping up because of the nature of this 1.618 ratio. This doesn't occur in other rectangles. It only occurs in this one. Because this is a diagonal across a square, that means that this is a 45-degree angle. And anything along this diagonal is a square. It's a square here. And if you took a look at this point, from here and then take a line up to here, this is a square. And then this remaining rectangle right here is another smaller rectangle, which is also 1.618. And again here, so this happens 4 times. So if I cut this off right here, like so, now I got a smaller rectangle, which again, it's the same ratio as the overall. And the interesting thing about this diagonal, these two diagonals, is that they have this, they reverse their roles. In the overall, we have a major diagonal that goes from corner to corner, and we have a minor diagonal that goes from corner to edge. Now if we cut it off like so, now those two lines have reversed roles. Now we have a major diagonal going from corner to corner, and we have a minor diagonal that's going from corner to edge. Those two lines reversed roles. So now we connect up these lines, these intersections, like so. We're going to connect up these 2 points. And then we connect them up horizontally. Now I said that all these points become significant in the composition. Now that doesn't mean you have to use all of the points. You can use any combination of points. You can use one of them, 2 of them. You can use all of them. You can use the lines. You can have features tangent to the lines. You can have features centered on the line. You can have corners coming to points. You can have corners or circles orbiting around points. 1 point, 2 points, any number of points, any combination of points, any combination of lines. Whatever you want to do, the imagination is your limit as far as how you utilize these lines and points.